Hello, welcome to Advanced Composites. Today is the third day of the ongoing week, which is the fifth week of this class. Yesterday and day before yesterday, we have developed three equilibrium equations related to sum of forces equation in the y direction and in the z direction. While developing the equation of equilibrium of force equilibrium in the z direction, we had also introduced two additional terms Qx and Qy. These are force resultants associated with shear stresses tau Zx and tau Zy. And the reason these additional force resultants had to be generated is to ensure that there is equilibrium in the z direction. Today we will continue this discussion and we will start discussing about moment equilibrium equations. So, we will discuss about moment equilibrium. Equation. Okay. So, once again we will draw a plate. The size of this plate is very small. So, this dimension is delta x and this dimension is delta y. That is my x axis, y axis and z axis. At the origin, which is O, we will list down all the moments which are present. So, at origin we have mx, my, mxy. So, these are the moments which are present at the origin. So, the first thing we will do is, so there are three equations we have to generate. So, first moment equilibrium equation, and this will be sum of all moments, and whenever we have to specify a moment, we have to say which around which axis it is trying to rotate. So, we will say sum of all the moments around y axis is 0. Okay. So, let us look at what these moments are. So, the first moment, so we will in this picture we will draw only those moments which are going to cause this plate to spin around y axis. So, this is my y axis. Okay. So, one moment which will cause this plate to rotate around y axis will be this thing. Okay. And what is this? This is called mx. So, remember, even though we call it mx, it is causing the moment to rotate around the y axis, and this mx, we call it mx because it is acting on this plane, which is, and the normal to this plane is the x axis, that is why. Okay. So, so if at the center this moment is mx, then at this edge it will be mx plus del mx over del x times del x by 2. And remember, this is not the moment, this is moment resultant. So, to find the moment we have to multiply it by the length delta y. Similarly, on the other side we will have a similar moment acting in the other direction. So, this is mx minus del mx over del x times delta x over 2. So, this is one moment which is causing it to rotate around y axis. Then what about my? my is not causing rotation around the x axis, it is causing rotation around x axis. So, we will not draw this my in this picture. Okay. The other moment which causes it to rotate around y axis is, so I will draw it, is myx. Okay. So, myx, so this is myx, this myx is caused because of sigma yx or tau yx. Okay. So, this value is, so this is myx, so this value is this thing. So, it is myx plus delta myx over del y times delta y over 2, because at the origin we have myx, and similarly on the other edge of the plate we have myx minus del myx over del y times delta y over 2. So, these are all the moments which are acting on this small plate element, which are causing it to rotate around the y axis, but there may be forces also which can generate moments. There can be forces also, and these forces could be, so nx, ny, we do not have to worry about those, because nx, ny, nxy, they are also already incorporated in mx and my and mxy. So, we do not have to, but we have also introduced two additional force resultants, qx and qy. So, qx acts in this direction, qx acts in this direction, right, and qy acts in, so qx also acts in the z direction and qy also acts in the z direction. So, qx and qy will also cause moments. So, which of these two is going to generate moment around y axis? It will be qx, okay, because qx is acting on this edge. So, qx is also going to generate moment. So, what is the value of qx on this edge? First, let us list down the value of qx on this edge. It is qx plus del qx over del x times delta x over 2, and on the other edge it will act in the other direction, qx minus del qx over del x times delta x over 2. So, qx will create a moment, but then this is not directly a moment. So, we have to multiply it by half length of the plate. Okay. So, now we write down all the moments around y axis. So, around y axis we write down mx plus del mx over del x times delta x over 2 times the length of the side of the plate, which is delta y, minus mx minus del mx over del x times delta x over 2 times del y plus mxy plus del mxy. Actually, I should strictly, if I am correct, then I should use myx. So, myx over del x, no, del y times delta y over 2 times del x minus myx minus del myx over del y times delta y over 2 times del x, and then, so these are moments, and then the moment created because of force qx will be qx plus del qx over del x times delta x over 2. So, this times delta y is what? This is just the force, this times, see this is a force resultant. The first I have to multiply it by delta y to create a force, right. So, this is a force and then I multiply it by delta x by 2, delta x by 2. So, that is the moment created by force resultant qx on the positive side of the plate, and similarly. So, now just consider this carefully. Okay. This force resultant will create, it is acting downwards. So, the moment it will create will be opposite of this guy, right. So, I have to put a negative sign here. So, we have to be careful about the signs. So, I have to put a negative sign here, right, because this is a negative and then this is the value of this force. Then the next thing we will do is, this force is acting upwards, so it will aid it. Okay. So, this is qx plus delta qx over del x, excuse me, delta, what do I do is delta x over 2 times delta y times delta x by 2, and this is equal to 0. Yes, there has to be a negative sign here. So, if you simplify all this, all these guys go away. Okay. Then the other thing you are left with is this gives you delta x times delta y divided by 2, and this term and this term add up. Okay. So, if you add up the first two rows, what you get is del mx over del x plus del mxy over del y times delta x delta y. Okay. This is what you get from these two lines, everything else cancels out, del myx del myx. Okay. And then from this line you get minus qx minus qx delta x delta y and plus del qx over del x, and what do you get here, delta x delta y, and delta x is squared, and this entire thing is divided by 2, right. See these terms, this is this term and this term, they will add up. So, this comes to be 0. Okay. Now, you can cancel out delta xy, and this goes away and this 2 also goes away. So, the only thing you are left with is delta x, and if I make this size of my element extremely small, I can make it extremely small, 1 nanometers, then this is can be dropped. If the size of the element is extremely small. So, this entire thing can be dropped. What I get is del mx over del x plus del mxy or del myx over del y minus qx is equal to 0. Okay. Likewise, so this is for the moment equilibrium equation around for all, adding, if you add up all the moments around the y axis. So, if you add up all the moments around y axis, this is what you get. Similarly, if you have sum of all the moments around x axis, we get del m x y over del x plus del m y over del y minus q y equals 0. Okay. So, now we have developed 5 equations. Sum of forces in x direction equals 0, sum of force in y direction equals 0, sum of force in z direction equals 0. And then we have also developed 2 additional moment equilibrium equations, sum of moments around y axis and sum of moments around x axis, they are equal to 0, and the related equilibrium equations are given here. Now, we will develop the last equation, and that is sum of moments around z axis are 0. Okay. So, let us again make a picture. So, this is x, this is y, and this is my z axis. Okay. This is my z axis. So, the which kind of a force will cause this plate to rotate around the z axis? What kind of forces will it cause to rotate around the z axis? First thing is that there is no moment, external moment, which is acting it to rotate like this. There is no moment which is being applied like this. So, the only question is which kind of forces will cause it to rotate. So, one force which will cause it to rotate is this guy, n y x, and then n x y, this will also cause it to rotate. Similarly, n y x, and of course, this is del n y x over del x, no, del y times delta y over 2, and this is this shear resultant is n y x minus del n y x over del y times delta y over 2, and then on this side we have n x y plus del n x y over del x times delta x over 2, and on this side we have n x plus del n x over del x times delta x over 2, and this should be a negative. Now, when we were developing relations for A, B, D, we said that tau x y is always equal to tau y x. Oh, sorry. So, this is okay. So, we will change the direction. What you are saying is right. So, this is like this, this is like this, this is like this, and this is like this, okay, and there is a negative here. So, that does not, okay. So, if you do all this, basically what it tells us is, see, this component, so this is n x y. So, this component, if you multiply it by delta y, that will be the force, that will be the force, and then you multiply it by that distance. So, essentially what I am trying to say is this component and this component, they have to be identically equal. So, this guy and this guy, they have to be identically equal because tau x y is equal to tau y x, and similarly this guy should be identically equal to this guy because tau x y is equal to tau y x. If that is the case, then we do not have to create a new equation for equilibrium, because if these forces are equal, then the moments which they will generate will be also equal, because the distance is the same. So, because tau yx is equal to tau xy, nxy equals nyx, and thus the sixth equilibrium equation is identically satisfied. We do not have to create a sixth equilibrium equation, it gets identically satisfied because of these conditions, because the equivalence of tau yx equals tau xy, and because if that is true, then nxy will be same as nyx. Okay. So effectively we have only 5 equilibrium equations, 3 for force and 2 for moment. So that concludes our discussion for today. Tomorrow we will extend this discussion, and we have these 5 equations, 3 for force and the other 2 for moment, and we will combine these 2 equations and we will actually shrink the number of these equations to 3. So that is something we will do tomorrow, and then we will also try to solve these equations subsequently. So that concludes our discussion, and then I look forward to seeing you tomorrow. Thank you.